Hi, everyone. So in this video, I'm going to show you how to conduct a dependent samples t-test in the two different ways you can actually do this. I'm going to show you how to do both of these in SPSS. So for this, I'm going to be working still with that hypothetical study I described in the slides where we have these guilt ratings from our sample of mock jurors. So the idea here was they were providing these ratings at two different time points prior to deliberation and then after deliberation, whether they thought the defendant was guilty or how certain they were, basically, and whether that person was guilty or not. So we have our pre-guilt ratings and our post-guilt ratings. So this is standard kind of example where you'd want to use a dependent samples t-test, right? Two collections of scores from the same group of people. So that's what we called a within subjects design. So just the same measure, basically, in this case, taken at two different time points, but from the same group of individuals. So each row here is representing one person in our sample, and then we have both of these ratings that are taken from them at two different points. Okay, so first, I'll analyze this just using the standard SPSS dependent samples t-test function, which they call a paired samples t-test, just an alternate name for the same procedure. So you're going to go to Analyze, Compare Means and Proportions. So this is exactly what you should have done for the one sample t-test. You can see that right here. But instead of that, we're going to select this right here, Paired Samples t-test. Okay, and then you'll get this menu will pop up. So it's going to ask for, okay, what are your paired variables? So what are the two variables that you've collected from the same group of people? Obviously, in this case, simple example, we only have these two variables that we're working with. And so this is where it's going to matter basically how you want the difference score calculation to happen is going to be dependent on the order that you put these variables in right now. So you have to kind of think about, what makes sense for my research question? What is the hypothesis I'm trying to test? How should I enter? What order should I enter these two variables in? So here, if you remember from the slides, the hypothesis we're working with is that post-guilt ratings should be higher, should be significantly higher than pre-guilt ratings. People should be kind of more convinced of the defendant's guilt after they have gone through this little group deliberation. So basically our hypothesis is just that post-guilt ratings going to be significantly higher than pre-guilt ratings. And then from there, you can decide what makes the most sense for how you're entering these variables here. So what probably would make the most sense in this case, I would say, is you want difference scores to be calculated as post-guilt minus pre-guilt. So you're getting the difference that way, sort of the positive. If you end up with a positive number, that's going to suggest a positive change from pre to post in guilt, like we're expecting. So if you wanted the difference scores to be calculated in that way, you'd want to put post-guilt in first as variable 1, and then enter pre-guilt as variable 2, and then that's how that's going to do the calculation, is essentially the difference scores are going to be post minus pre. So it's going to be whatever you put in first, whatever variable you have as variable 1, minus whatever you put in as variable 2. Okay, and then that's pretty much it. We're also going to want to get an effect size from this, but you can see everything there that we'd want is already checked for us. So you don't actually have to do anything. We have estimate effect sizes checked, and then calculate standardizer using, that's just asking us kind of what we want in the denominator of our effect size calculation. And here we're just going to be using standard deviation of the difference. So our sample of difference scores that it's going to calculate automatically for us, essentially. It's going to be using whatever the standard deviation of those difference scores is in the denominator of that Cohen's d calculation. Okay, so you can hit OK. And then you get a couple different tables here. It's going to give you, like, here's your means for each group, sample means. So you get some basic descriptive statistics. You get sample size, standard deviation. All that stuff is good to have. Standard error of the mean, right? So that's the standard deviation of the sampling distribution, essentially, for each of these variables. But the main thing we're interested in here is going to be this table, or these two tables, really, because we also get the effect sizes down here. So paired samples t-test. For now, you can pretty much ignore these other figures that are here if you're just concerned about doing the significance test, essentially the NHST significance test. You want your t-score and your p-value. So this is where you're going to find those two pieces of information. What is our t-score in this case? 0.88 if we round that. And then p-value is depending on whether we're doing a one-sided test or a two-sided test. In this case, one-sided test would make more sense because we do have a specific directional hypothesis. Again, we're saying post-guilt ratings should be significantly higher than pre-guilt ratings. So we'd be looking at the one-sided P. And so we see in this case, that's a non-significant effect, essentially. So our p-value is above standard significance level 0.05. We'd say, okay, we don't have evidence here, essentially, that there is a significant difference between these two. And then we can look at, if you want the effect size, which this Cohen's d effect size, again, is just telling us how many standard deviation units apart are the two means. And so we get that information here under point estimate is the main thing you want to be looking at. So what is our Cohen's d? In this case, 0.36 with rounding there. Then we can go back to the slides and just make sure we found the same statistics when we were doing all this by hand. So you have your t-score here, 0.88. That checks out with what we found. And then you had your dependent samples, Cohen's d calculation here as well, found 0.36. Okay, same thing we get here, 0.36. So that's good. And you can always do that, by the way, whatever I'm asking you to do these things by hand, like in the homework, I'll be asking you to do that. Just go plug the numbers into SPSS after, run these analyses, and you can double check all of your by hand calculations. Okay, so now that's the way you would probably typically go about doing this, running your dependent samples t-test procedure. But as I mentioned in the slides, there's a second way, actually, that you could go about getting the same results. There's a essentially conceptually equivalent second option here, which is you can do a one sample t-test, but not using these pre-guilt and post-guilt scores individually. You're just going to have to first calculate different scores, and then you just be doing a one sample t-test on those different scores instead of on the original, these like raw scores we have here. You can just run the one sample t-test on your different scores against a test value of 0. So then it kind of becomes basically the same question, just phrased a little bit differently. So before we're saying, is post-guilt significantly higher than pre-guilt? If we calculate the different scores, all we're going to be asking then is, are the different scores significantly higher than 0? Different way of asking the same exact question. So if I do that, I should get the same exact statistics, and I'll just quickly show you that that is the case. So obviously the first thing we're going to need is the different scores, which we don't have here right now. Pretty easy to get those, though. This is the first time I'll be showing you this function in SPSS right here. If you go to the Transform tab, you see this option at the top that says Compute Variable. So click on Compute Variable, and this is going to allow us to basically take any existing variables we already have in the data set and perform some kind of mathematical operation on them. So pretty much any mathematical operation you want to do, you can do that through this compute variable window. So up here, the target variable field, that's just basically where they're asking for a name for this new variable that you're going to compute. Just give that variable a name. So we're doing different scores. We can just call it difference. We could call it the different scores. And then how are those computed? Again, the way that would make the most sense for me to do in this case is post-guilt, and then subtract from that. And by the way, here you can either double click on this, we'll send it over here, or you can hit the little arrow here. Either way works. So I'm just double clicking, and it appears there. So what this is telling SPSS to do essentially is create a new variable that's called difference scores. And that variable is going to be calculated as post-guilt minus pre-guilt. Okay, we hit OK. And then that variable will just appear for us like this in our data set. Okay, so perfect. You can double check, make sure SPSS's work is correct, right? 5 minus 2, this should be. We get 3. 5 minus 3, we get 2. Seems like things worked out in the way that we wanted them to. Okay, and then from here, pretty easy. We're just going to analyze, compare means and proportions. We want a one sample t-test now instead of the paired samples t-test. And we're going to submit not, again, pre-guilt or post-guilt. We're going to submit the different scores now to this one sample t-test. And what is our test value going to be? So this is where we're selecting for one sample t-test, what population mean or what just value do you want to test against? So you're asking, are my different scores, in this case, significantly different from what value? So for us, it's a 0. Again, we care about whether different scores are significantly higher than 0. So we'd be expecting a positive t-score, and can leave this checked again for estimate effect sizes. That's fine. And let's see what we find. Okay, so again, we're going to be most interested in this table right here. One sample t-test on the difference scores against the test value of 0. T-score we find should be the same as that we found up here for the paired samples, 0.877, and again down here, 0.877. Perfect. Okay, p-value should be the same, right? So long as you have the same t-score, that's always going to be the case. P-value should be the same, 0.210 and 0.210. We get the same thing there. And last but not least, the effect size. Cohen's d, we found 0.36, and same exact thing here. Right, so essentially, you can do either of these. It doesn't really matter which. They are conceptually equivalent, but just a little bit different in terms of how they're actually doing the underlying analysis. So those are the two different ways you can go about running a dependent samples t-test.